is Jack Jackson. In the most recent set of videos, we derived these derivative formulas for the 6 basic trig functions. Let's review real fast. The derivative of sine x is cosine x, the derivative of tangent x is secant square of x, and the derivative of secant x is secant x times tangent x. The ones that start with co here for the original function all have minus in front of them, and they're just the co-functions of what we get over on this side. So the derivative of cosine x is the opposite of sine of x. Derivative of cotangent of x is the opposite of cosecant square of x, and the derivative of cosecant of x is the opposite of cosecant of x times cotangent of x. And what we want to do in this video is to use these 6 rules along with our earlier rules of derivatives to do some basic examples of finding derivatives with trig functions. So the first one, what I'd like you to do is try to do these yourself and then check your work as we go along. So for example, see if you can do the derivative of sine of x squared. Okay, if you haven't done that one, press pause and do it now. Okay, so you're back. So the derivative of sine of x squared, we want to think of u as x squared. Then we got the derivative of sine of u. That's the one we know. Derivative of sine of u is cosine of u times the derivative of the u, since we did a substitution. Of course, the derivative of the u is the derivative of the x squared, which is just 2x. U is x squared, so we have 2x times cosine of x squared. Alright, you do this one. What is the derivative of the cosine of 2x cubed? Okay, you get a lot more out of these videos if you stop and work the problems yourself whenever I ask you to do that. So why don't you try that right now. Press pause. Okay, well, it's very similar to the last one. We're going to, well, actually, do I even work that one out? I don't have that worked out. What do you say we work it out right now? Okay. Okay, so what are we going to do? We're going to think of this as the last thing we do is we let this part right here be u, and so we're letting u equals 2x cubed. Okay, now the derivative of cosine u is just, starts with a cos, so it starts with a minus sine of u times the derivative of the u. Okay, now du over dx is the derivative of 2x cubed, which is just 6x squared. So now, in the next step, I can substitute in u is 2x cubed, du over dx is 6x squared. There's the answer. Usually you'll write it this way. We'll put the 6x squared in the front with the minus sign, and we'll leave it like that. Okay? Now, perhaps as you get better at this, you'll get to the point where you can actually do that problem entirely in your head. Okay, here's another example. Again, you may want to try this one on your own first. The derivative of e to the x times cosine of x. Press pause and come back. Okay, so this is the last thing. Here's a product, so we use the product rule. It's the first times derivative of the second plus the second times derivative of the first. The first factor is e to the x. Then we have the derivative of cosine x, which is minus sine of x. Plus, then we have cosine of x times derivative of e to the x. Derivative of e to the x is e to the x. This is the answer. Let's clean it up a bit by factoring out the e to the x. That leaves a cosine x and a plus a negative sine x, which I'm going to write as cosine x minus sine x, and with the e to the x times that in the beginning. Exercise 31 is going to be very similar. See if you can work it out now. Press pause. Okay, let's go ahead and work that one out here in the video. So let's work out a solution to that. So, well, it's a product, so let's see. So it's the first times the derivative of the second plus the second part times the derivative of the first part. There we go. That's the product rule. And then from here, we can simplify a little bit. Or we can take these derivatives. Derivative of sine x is cosine x. And that gets rid of this derivative because we just did it. And we do this derivative, we get the original function times the natural logarithm of the base, because that's an exponential function. Now they both have a 3 to the x, so I'm going to put that out front. And then we have parentheses, what's left? Well, we have a cosine x, and then we have a plus sine x and an ln of 3. I'm going to put the ln of 3 first. Doesn't really matter. Alright, that's a pretty good way to write it. Let's leave it like that. Now remember, you can check all these in your calculator, and I strongly encourage you to do exactly that. Alright, here's another example. And see if you can work this one out as well. The derivative of sine cubed x plus 4 times tangent of x. And you want to try to maybe leave your answer in kind of a factored form if you can get it there. Okay, go ahead and work this one. Press pause now. Okay, you're back. Let's see what we got. Well, first of all, the last step here is a sum, that sum here, so we use the sum rule. So it's the derivative of the first part plus the derivative of the second. And the derivative of 4 tangent of x, I can bring the 4 out front of the derivative sign. So I use the sum rule and the constant multiple rule there. Derivative of tangent is secant square. Derivative of tangent of x is secant square of x. And sine cubed. Now I'm going to do, I'm going to think of this as a substitution. I'm going to do the substitution in my head this time. U equals sine x. So this is u cubed. So we're going to have 3 times u square times the derivative of u. Derivative of sine is cosine, so it's 3 sine square of x times cosine of x plus 4 secant square of x. You could leave it like that. If you switched it all to sines and cosines, then we're getting, and then get a common denominator by multiplying the first part by cosine of x over cosine square of x over cosine square of x. You could write it as 3 sine square of x times cosine cube of x plus 4 over cosine square of x. Either one of those are legitimate ways to write it. Now, one thing I do warn you about, if you're picking up a calculus textbook and you work out your answer to a problem that has either logarithms or especially trig functions in it, and you get your answer, and then you look in the back of the book or look up the solution, and you check it, and sometimes your answer may not look the same. For example, the book may have given the second answer when you came up with the first one, or vice versa. They're both correct answers, they're just different forms. So be sure you use your calculator to check, as well as looking up things in the books. Okay, so here's a pretty somewhat similar example. See if you can do this one. The derivative of sine to the 5th of x plus 7 times cotangent of x. Go ahead and press pause now. Okay, well, you're back. Hopefully you've worked that one yourself. Let's go ahead and work it out here too. Okay, let's okay, so we have this. The first thing is it's a sum, so we're going to think of it as the sum rule. So it's the derivative of the first part plus the derivative of the second part. Now I'm also going to use let's see, we're going to do a couple of things here. Okay, so this is u to the 5th. So what we get is, Let's do a little copying here. So we're going to get 5 times u to the 4th power, and then we have just the derivative of the u. Plus, this is going to be the 7 we could bring out front. Okay. Okay, derivative of sine of x is cosine of x. And then this derivative sine goes away. Derivative cotangent of x, let's see, is minus, starts with a co, so it's minus. But notice the parentheses here, so this is still multiplication, not subtraction here. So it's the opposite of, let's see, cosecant square. So just get rid of a lot of these extra parentheses that we don't need. So let's just leave it like that, for example. And again, we could rewrite this one in a couple of different forms, perhaps using some different trig identities. That's one way to do it. All right, here's another one. The derivative of e to the power sine of 2x squared minus 1. See if you can work that one out. Press pause now. Okay, now this one's interesting because we end up eventually doing 2 substitutions. And I strongly encourage you to formally write out the substitutions that you're doing, particularly if you have to do it twice. So notice the last thing is this is e to some power, so we let u be the more complicated power here. So the derivative of e to the u is e to the u times the derivative of the u. I'm going to leave this e to the u for right now. U is sine of this thing here, so I'm going to think of that as the last thing is sine of something. We'll let the something be a different letter, let's say v this time. And so this is sine of v. The derivative of sine of v is cosine of v times the derivative of the v. So then we're taking the derivative of the 2x squared minus 1, which is 4x. V is 2x squared minus 1. U is cosine of, no, U is sine of, not cosine of. Look at that. Typo there. Let's fix that. Alright, so let's see if we can fix that. We'll put the 4x usually is put in the front. So 4x, an e to the power sine of 2x squared minus 1, and then the cosine of 2x squared minus 1. So u is sine of 2x squared minus 1. V is the 2x squared minus 1. Okay, there we go. Alright, here's another one for you to try. Go ahead and work this one out yourself. Press pause now. Okay, let's go ahead and work this one out as well. So we want to think of this, we want to make a substitution here. And we pick whatever letter we want, as long as it's not x. So let's let u be the power here. And so this is cosine. This is e to the u. All right. Well, what's the derivative of e to the u? Well, it is e to the u, right? Well, almost. It's e to the u, but since the u and the x are not the same, we still have to take the derivative of whatever the u is. Okay? Now I'm also going to think of this as cosine of another letter, v, w, whatever. I'll call it w this time. Cosine of w, and the w is going to be the 2x cubed minus 7. Okay, so this is, well, it's this, but u is cosine of w. Oh, okay, we know how to do that, right? Derivative of cosine w is the opposite of the sine of w, but then we have to do the derivative of the w. Okay, let me put the minus out front, and then the sine of w here. We'll come back and substitute in the u and the w in a minute. Now this w, I need to go ahead and substitute in what it is. Okay. And now we can actually do this. Take this derivative and actually do it. And that is 6x squared plus 0. And so let's substitute back in. First of all, let's bring the 6x squared to the front here with the minus. Okay, what was u? U is cosine of 2x cubed minus 7. Let's just take that and put it in place of the u here. And what is w? 2x cubed minus 7. Let's put that in place of the w here. And now we have our answer. So there's another example where you have to use the chain rule twice. I've done this a lot with students, and a lot of students, even the ones that are pretty good at doing the chain rule once, oftentimes have some difficulty where they have to do two substitutions in the same problem. So, you know, just be careful with that, and there's where I think it's easier if you actually write it all out. All right, here's another example. How about the derivative of the secant of 4x cubed? See if you can work that out. Well, hopefully press pause now. Okay, now you're back. Hopefully you saw, like I have here, that we want to let u be 4x cubed, and we're taking the derivative of the secant of u. Secant of u, the derivative is secant u tangent u times the derivative of the u. Derivative of 4x cubed is just 12x squared. Substitute the u back in place here and put the 12x squared in the front, and we got 12x squared times secant of 4x cubed times tangent of 4x cubed. Alright, how about the derivative of the cosecant of 7x to the 4th? See if you can go ahead and work this one out now. Press pause and work this one out. Okay, so now we're back. We want to look at this, and so we have this derivative here, and we make our substitution. And let's say I'll typically use the letter u, but you could be something else. We'll let the u be this here, so that this part right here becomes u. Alright, well that's the derivative of cosecant of u. Yeah, we know how to do that. Okay, the derivative of cosecant u is cosecant of u times cotangent of u. And the ones that start with co have a minus in front. But we also have the chain rule going on here, so we can't forget that we need the derivative of the u. We might up here could actually, another way you could do the substitution is write it out up here. That this we can see is 28x to the third. So we can substitute that in here. In fact, well, let's do it like this. So du over dx, or d over dx of u, is 28x to the third, which I'm actually going to move to the front here. And then the u is the 7x to the fourth, which I'm going to replace this u and this u with it. So there we go. Okay, so there are a few examples there where we've used these basic trig functions along with some other rules like maybe the chain rule, the quotient rule, and the product rule, the sum rule, different rules. We can put these together, and along with things like power functions and exponential functions, and build up some new examples. So those are some pretty basic ones there. We're going to probably a little bit derive a couple more rules. The next video we'll talk about inverse trigonometric functions. Then we'll talk about some hyperbolic trig functions, and then we will then do maybe some videos where we do several more examples involving these new kinds of